This looks like an ordinary crop, but it might hide the secret of a new renewable fuel for airplanes or new greener ingredients to replace fossil resources used to produce plastics. How and what are the expectations and the challenges involved? These researchers are trying to find out at this experimental agriculture plot.
Here in Greece, agricultural engineers are growing plants which could promise future greener fuels. They're studying their oil content, yield and adaptation to the Mediterranean climate and predominant soils. Each of the plants has advantages and disadvantages.
This is Castor. It's an annual oily plant from the Mediterranean. Its annual production is around 4 to 5 tons per hectare with a high oil concentration of around 40 to 50%. This is Cuphea, a plant that comes from America. It's still in the experimental stage. Its yield is still very low, less than 1 ton per hectare in seeds, and it has just around 20% in oil concentration. And this is safflower, a plant from Asia. We think it's very good for Mediterranean agriculture. We have varieties in autumn and spring, suitable for every variety of climate and soil. We think it can be in agricultural practice on a horizon of around 5 years.
But where are the chemical characteristics of these plants analysed?
Highly specialised labs like this one in Lille, France, are where chemists research how green ingredients from plants can replace existing molecules which are currently extracted from fossil resources. And the results, they say, are encouraging.
We've developed a new type of aviation fuel that we've already tested on a real reactor. We've made 15 cubic meters of a fuel mix. Between 10 and 20% of this mix came from a new ingredient from plant biomass. This new green ingredient made the fuel more efficient and less polluting. We're now seeking a certification for this new ingredient, because once you have a new aviation fuel, you need that certification to be able to use it in an aircraft.
And once green oil is extracted from the plants in special biorefineries, what happens to the biomass waste?
Back in Greece, this gasifier helps scientists find out which plant waste produces most gases, like hydrogen or carbon monoxide, which could eventually be used to produce heat or electricity. And they say the final waste can be easily, harmlessly recycled.
The only thing left after the use of biomass content from this gasification is ash. This contains a very small percentage of inorganic content from the biomass, like potassium, calcium or iron, all of which were extracted from the earth by the plants. After gasification, we can usually replace them in the earth as compost, closing the cycle of these plant contents.
This project in Greece is just one of many funded under the umbrella of what is known as JTIs, Joint Technology Initiatives, a wide array of public and private common initiatives promoting European research in various strategic areas.
And those areas include bio-based industries coming up with greener everyday products, and developing a new generation of vaccines, medical treatments and medicines, and systems to manage European airspace better and design cleaner, quieter aircraft. Along with developing safer trains and railway infrastructure, and better tools to manufacture more efficient electronics. And finally, technologies to expand the use of fuel cells and hydrogen in industry, energy and transportation.
Welcome on board a bus which is truly different from many others in Europe. Why, how and where? Let's take a ride on the public transport of the future.
This bus in Brugge, Switzerland runs on hydrogen, partly produced using renewable energy. Similar buses run in Bolzano and Milan, Italy, and also in London and Oslo. This bus uses hydrogen fuel cells to produce electricity while emitting only water vapour. It's cleaner, but also quieter than a diesel bus.
Yes, it is quieter. It doesn't sound the same. The journey's less jerky, it's quite enjoyable. It drives smoother. Slower, without stress, it's pretty good.
Driving this, the biggest difference is that the centre of gravity is higher where the hydrogen is placed. The bus carries a ton more weight than a normal diesel bus, and when going round corners you do notice the difference compared to a normal bus.
The bus was built here in Mannheim, Germany, where hydrogen buses are for now assembled as prototypes. Researchers say that industrial production could start as soon as the technical know-how improves.
The disadvantages of these vehicles is that the price is still well above the price of a diesel bus, and operators have to set up the infrastructure for hydrogen filling stations.
So researchers keep working at labs like this one back in Switzerland. They want to produce more efficient hydrogen fuel cells.
The most important factor is cost. All parts must be more affordable, otherwise the fuel cell drive system is too expensive. The second factor is duration and endurance. The fuel cell must have the same life expectancy as the vehicle. And the third issue is efficiency and power density. That means we want to transform as much energy from the hydrogen as possible into power, and do it with as little weight and volume as possible.
With that in mind, scientists are already designing and building future hydrogen buses in factories like this one in Belgium.
This prototype will soon be running around Antwerp, and others are already operating in San Remo and Aberdeen, with autonomy of around 300 kilometres.
The main features of this bus is, of course, that it's a hybrid fuel cell bus. A hybrid means there are two sources of traction. One is the fuel cell that provides electricity directly to the electric motors, and the traction batteries, which do the same thing. All of it is controlled electronically so that the energy utilization is maximized.
The prototype bus has to be filled at special refuelling stations. To fill the inboard hydrogen tanks takes around 11 minutes, depending on outside temperature. Safety regulations are similar to those of a normal petrol station.
It was a challenge to build a compact refuelling station like this one. We needed a station that could be easily installed anywhere where we have access to a hydrogen source. And we had to ensure safety measures were respected and embed a security system allowing remote surveillance. That was the main challenge of this project.
A hydrogen bus is around 6 times more expensive than a normal diesel one, and maintenance costs are also higher. But city bus operators would still be prepared to invest under certain conditions.
We're in an experimental phase at this point in time, also from the economical point of view. I think in time the prices will go down, of course, and that opens some possibilities in the middle or in the long term to incorporate more hydrogen buses into our fleet.
Which is why, say researchers, more research is needed to move towards the hydrogen bus of the future.